Amira, are you there?
Yeah, hello.
Amira, now I just sent you a file, that exam 2. Can you open it and share with me? I mean, your screen.
Okay.
Okay, so you are going to solve a few of them. Can you go to 3B? What is 3B? Okay, 3B is done. About 5A. Okay, that's also done. Question 6. All right. Can you zoom in a little bit?
Yeah.
Yeah, can you? Okay, that's good. You found actually that's find the height of the solid, right? That h. What was it?
I can't remember.
I think it was it is 3, it is 5. So that is 100. 100 is square root of 75. 5 times square root of 3. Okay. So the height equals 5 times square root of 3. Okay, let's just write next to A. Okay, we know the heights. 5 times square root of 3. Okay. So now you got the idea. We know how to do this. Can you find the volume of this frustum? We know that how do you find the volume of a cone? It's just 1/3 times base area times height, right?
Yeah.
Okay. So we know the height of this h. So now I'm at the top of this frustum. Can you draw the small cone? Can you? We have space? Okay, not space. Okay, can draw like this. Okay, the heights h. Okay, let's say this h. The problem is just we need to find this h, right? If we know this h, then we can find the volume of the small cone, we can find the volume of the big cone, and then we can just subtract this, we will get the volume of this frustum. Now the question is, how do you find the value of this h?
I'm not sure.
Using the similar triangles again.
Oh.
Right?
Yeah.
Okay, can you find it? First, can you draw the triangle, Amira?
Which triangle?
If you just cut this from the middle, right? The cross-sectional area, we have this kind of triangle, right? From here to here. So here we will have this kind of triangle. Right? And this top part is from here. So this one is h, and this one part is, you have already found it, that is 5 times square root of 3. This base radius, what is it? It is 8, right? And this one also is given 3. As you see here, this small triangle is similar to the big triangle. Hey, can you draw like this? That's a right angle triangle.
Oh.
Yeah, slant height, we don't need it. Okay.
Yeah, so now do I just times
Also,
this by
also write 3 Amira there. That
3?
one is
Okay.
3, right? This one.
Yeah.
Okay. 2.6. What is 2.6?
I did 8 divided by 3.
Now, first, can you just write the proportion that these ratios are equal, right? X. I'm going to write like this because this small triangle is similar to this big triangle, so their corresponding sides are proportional. That means that x over x plus 5 times square root of 3. I mean, why don't you just write like this? X over x plus 5 square root of 3. It looks much better.
I don't know, I'm just used to writing it this way.
Yeah, what's one fraction, but for expression it's more confusing.
Okay, but
Equals,
was
that is
this
equals 3 over 5, right? That's equal to over 3 over 5.
yeah, but was this incorrect, this
8,
bit?
8, sorry, 3 over 8, sorry, 3 over 8. Not... What is incorrect?
This am I meant to do that?
Yeah, but 8 over 3 is not exactly equal to 2.6. Is it equal to 2.6? Not exactly.
No, it's 2.6 reoccurring.
So you have to estimate this in the final answer, not in the middle of the solution.
Wait, what do you mean by that?
Because now 8 over 3, right? Or 3 over 8, whatever it is. But here, instead of this 8 over 3, if you use 2.6, if actually you have to go through like maybe 3 or 4 steps, every time you just go to another step, that error gets bigger and bigger because 8 over 3 is not equal to 2.6, right?
Yeah.
So the exact value is 8 over 3 or 3 over 8. Use this number in your final answer, then you can estimate this.
Oh, okay. Is this correct so far?
Did you cross multiply here? 8x,
Uh,
3x. So if you cross multiply here, 8x, right? 8x equals 3x plus 15 times square root of 3. This thing, if you cross multiply.
oh,
We are solving this equation for x.
okay.
Delete it. First cross multiply. Just cross multiply. I don't know how you are going to solve this. Okay. All right. Just use this number. The final answer we can. Now we know x.
Mhm.
So now let's find V1 and V2. Volume of the small cone, volume of the big cone. Can you
Okay.
just V1? What is V1? 1 over 3. I made a cone, right? What is the volume of the cone? 1/3 times pi r squared times h, right? What is 1/3? Or you put here?
Yeah, here.
Oh, okay, good.
Can I do that as well? Because that's how I do it in school.
You can do this, but usually when you're using this one, for example, here you're going to calculate, right? First, if you just write the formula, then if you substitute like this, it's fine, because otherwise it may not be clear. Okay, here, then substitute all the values.
Okay.
Because that shows your method, what method you are using, and after that, your calculation. You can write 1/3 in front because coefficient is always written in front of the variables, right?
The height,
So
okay.
yeah, for r, what is r? R equals 3, right?
Yeah.
So why don't you substitute 3 for r?
Should I put it into a calculator?
No, not now. Let's just simplify and leave it like this. It will be calculated later in the last step. Just simplify. Can you simplify V1? So 3 cancel each other, right? It is 9 times square root of 3 times pi. Okay. So now find V10.
Is that correct?
Yeah, that's correct. Pi r squared times height. Height is 3 times square root of 3. Okay. Continue.
Okay.
Okay. Okay. Now let's find V. V equals the difference of these two volumes, right? Let's say V equals V2 minus V1.
Yeah.
Now you may use a calculator to write the answer. Let's see.
Okay. What is it, centimeters? Yeah. That's what I got.
879.
Yeah.
Good. 879.
Yeah, I didn't realize that. I get the method, but I didn't realize that I could make the 3 and the 8 would be like similar triangles. I didn't realize I could do that.
Okay. It's good. It's okay. At this time, you know that, but you'll see that every time you deal with this kind of problem, use this idea. Not only now, maybe in the future. For example, let's say when you go to university, the first year, most students, if their major is somehow related to math, they must take calculus. In calculus, and also it's used a lot, this idea to, how to say, what the volume of any kind of solids. They use this idea and they generalize this. And in most cases, actually, you're using the same idea. At this time, you know how to do this. It is exercise 2, question. What question is it? 6. 8.66, right? Did we get 8.66?
That's strange.
No, 8.66 actually is high. Question A.
Oh.
Right? And question B, what is it? 880. Is it?
Yeah, if you round it up.
Yeah. It says estimate. What's the question? Can you move up? Does it say calculate the volume of 2 appropriate cones and use your result to estimate the volume of the solids? Anyway, it doesn't say anything. If it doesn't say anything, we should leave our answer characters 3 significant figures usually. Okay, no problem. After all, you got the idea. Now you know the method how to do that. But in similar question, Amira, next time, not next time, in the future, if I ask you the surface area, that will be more challenging.
Oh, okay.
The volumes are easier, but surface area, a similar method, but still more challenging. Anyway, that was question 6. What is 7b? Can you go to 7b?
This. Yeah, we did a similar question to this, I think.
Yeah, can you do this again? Let me see. I give you 4 minutes. I don't give you any help, any hints. After 4 minutes, we will discuss. Let's see. I'm gonna start now.
Do both, I just have a question about the actual question and understanding it. Does this mean that the 2 pipes will fill it, like will they both fill it in that time together or separately?
Yeah, together. We have a tank, right? We have one pipe here, the second pipe. If you open them at the same time together, after 1 hour and 20 minutes, it will be full. That is what does it say actually, the first sentence. If the 2 pipes are to fill the tank individually, it means either this one just turn it off, open one tap, right? Let's say this is tap 1, this one is tap 2, right? So we have 3 possible cases, right? Either we open them together, or we just open one of them, right? And we have other different cases. But in the question, the first one is, if you open both taps at the same time, it takes only 1 hour and 20 minutes to fill in the tank. And the second part is, if the 2 pipes are to fill the tank individually. It means that here maybe 2 different tanks here, the same volume. And here we have tap 1, and this one is tap 2, right? So if you just open this tap here, the smaller pipe will take 2 hours more than the bigger pipe to do so. Find the time each pipe will take to fill the tank separately. Do you understand the question?
Yeah.
Okay.
What would I do after this?
I mean, why did it stop? You forgot how to solve this, or
Partially that as well, but also like the formula.
yeah, actually, you don't have to memorize the formula. Here it's very similar. This question, I mean, to what is it? Distance, time, speed formulas. Because the first thing you have to understand here is what we are talking about here. What's going on here, right? So we are talking about a kind of tank. Let's say it is three-dimensional tank, of course. And since we are talking about a tank, it has certain volume, right? Let's say the volume of this tank is V liters, right? And here we just actually put two taps. And actually these taps, if you just open them, right? Maybe this one is smaller pipe, this one is bigger pipe. We don't know. That means that the rates will be different. And let's say the rate of this pipe is R. What we mean by rates, since actually we are talking about time, right? And the volume, that means that the rate of this type means R liters per minute. It means that if you just open this tap, in 1 minute, it discharges or pours R liters of water into this container, right? And how about this big one? Let's say it is capital R liters per minute. It means that in 1 minute, this tap pours or discharges R liters of water into this container, right? And okay, now the question number one is assume that if I just open this tap, okay, alone, now this one is closed. After a certain time, right, this container will be full of water. Now, how much time does it take? I don't know. Let's say here it is, it takes T1. And the same thing, let's say now it is empty. If I close this tap and open this big pipe, for example, this tap. Let's say for this, it takes, okay, let me just use like this. Just T, Amira. And this one is capital T minutes. Okay. So what does it mean that it takes for the smaller pipe T minutes to fill in the tank? That means that we have this relationship, this V, right? After T minutes, right? This pipe will discharge this much water, because after 10 minutes, it will be full. And if you open the big tap alone, after capital T minutes, right? The rate is this one, right? It will discharge this amount of water that's equal to the volume. The container will be full means this. And how about if we open them together? What does it mean? It means it takes some time, right? I don't know, what is it? It's some time, let's say T star. And now, since both taps are open, in each minute, how much water is poured into the container? That's R plus lowercase r. I mean, this thing you should understand. The rest is easy. Just if you understand how we are modeling this, the rest is just substitute the values and solve the equation.
Okay.
So using this one, I'm going to delete everything. On the left-hand side, can you just write, for example, it says that the smaller pipe will take 2 hours more than the bigger pipe to do so. So using this in terms of only one thing, can you write these two equations?
Okay.
Delete here, I mean, just write here. V equals something, V equals something. That's first two equations. Let's say this for the smaller pipe or tap, it takes T minutes. So it is T times R, right?
Mm-hmm.
How about for the bigger pipe? What equation can you write for the bigger one in terms of T?
It will take 2 hours less in terms of time.
Yeah.
So do I need to convert the hours to minutes?
No. So just write everything in hours.
Oh, okay.
Yeah, actually, it doesn't matter. Either you need to write everything in minutes or everything in hours. It doesn't matter which one is easy for you. But here, hours is better, I think. I mean, the second equation for the bigger pipe, right?
Yeah.
So what is its rate? It's capital R.
Oh, okay.
That is for the second bigger pipe.
Mm-hmm.
Now, this line, yes, erase it also the second one, the last one. Okay. Now, right, for the third equation, for this one, it's given here, right? 2 pies in 1 hour and 20 minutes. Change this into hours and write the equation. If you just open them together, how long does it take? 1 hour and 20 minutes, right? So it is 3. Okay, that's it. From the first and second equations, we can find that's small r and capital R in terms of V and T, right? And substitute in the third equation, then we get the answer.
Yeah. Um, is this correct?
Yeah, that's correct. So now solve for T. Can you also take this V out? I mean, the V is a common factor, right? Immediately take this out. Always in math, computer-wise, actually simplify expressions every step if possible. But take V out. The V is a common factor, right? You can just write it as V times 4 or 4 over 3 times V times then in parentheses 1 over T minus 2 plus 1 over T. And on the left hand side also write V. Good. Well, I mean, why are writing V again and again? Just cancel it out and multiply both sides by 3 over 4V. So 1 over T minus 2 plus 1 over T equals 3 over 4, right?
What, like that?
Yeah.
Oh, okay.
I don't know how you solve this, but usually in this kind of questions, you just simplify and express the left-hand side as a single fraction and cross multiply. That's the fastest way. Oh, no, can you, yes, okay, Amira, can you try that method? I know that you're going to solve this method. That's why I told you. And you will decide which one is shorter. This left-hand side, can you express this? Actually, you are supposed to do this in this step, simplifying this fraction, doing 2, 3 operations at the same time. Multiply both sides by 3 over 4v. At the same time, can you just simplify these fractions or algebra fraction and write them as a single fraction? What do we get here? Then we get like this, right? T minus 2. And here we have t, so here we have 2t minus 2. On the left-hand side, we have 3 over 4. If you cross multiply, is it a shorter? When you do like this is correct, but this is longer way. Now you need to bring it to the same denominator of these 3 fractions.
Oh, okay.
Yeah, now cross multiply. While doing this, also you should expand this. T squared minus 2t, right?
I'll do it here.
I mean, why don't you remove the brackets and take to the left-hand side? I don't know why you are doing this. While you are taking it to the left-hand side, why don't you expand this? Right, 3t squared minus 6t, so that you don't have to. Minus what? Minus 8t. Take this to the left-hand side. Expand and take it to the left-hand side. Okay, minus 8t plus 8.
Left-hand side. I was going to expand it afterwards, but
Yeah, I think we can solve this by factorization, right?
mm-hmm.
Okay, now let's get back to the question, Amira. What was the question?
Find the time each pipe will take.
Okay, so what's your answer?
The bigger one will take this much time, and then the smaller one will take this much time.
No.
No?
These two things are the solution of the equation, not the answer to the question. Actually, what is big one? The big one is this thing, right? T minus 2. Right? This one is big one.
Yeah.
So capital T equals T minus 2. So now using this value, you need to find capital T and capital T. That is the time that the big pipe takes, right? Or small pipe. This one small pipe or big pipe? T is small pipe, right?
This is the big pipe. T is the small pipe, yeah.
Oh, big pipe. Then we need to find the time actually for the small pipe. Okay then. What is that? It is T minus 2, right?
Yeah, that's the big pipe.
Okay. So can you find this capital T for this capital T like this, capital T, the corresponding values. What do you get? Then we will answer the questions, because still we are not sure actually which one is the suitable answer. Now we need to pick the suitable answer, right?
So it has to be this one.
Yeah, because time cannot be negative here. So the first one is rejected. So dot, dot, dots, small pipe takes 4 hours. And big pipe takes 2 hours to fill the tank alone or separately.
Okay.
Okay, next time I will ask similar question, but different question. Let's see. That was question 7B. Okay, can you move to 9A? All right, we did this. 9C.
It was this one.
Okay, we already did this, right? 11. Okay, and 12, done.
Yeah.
Okay, good. Nothing to do with this test. Okay. That's all about tests. So like this also, I will send you one more test, Amira, and try to do this by next Friday. Okay, within 5 days, as I told you. If you can do it before our Friday, try to do this until Friday. We will see. If you can do this earlier, we will discuss on Wednesday. Otherwise, we will see this together on Sunday. And there will be 14 questions. Okay, now you will have more time, 100 minutes for the test. And during the time, if you're tired, you may have some rest, it's fine. But the important thing is, in given time, in 100 minutes, can you do the test or not? Because after all, when you're doing for a time, that's also another challenge for the student, okay? And this is test 2, right? Now you're gonna have test 3. After that, we will give some break to the test and do some new topics. And after second test, that is test 4, 5, 6, it will cover more chapters. Now this test 1, 2, it covers only 3 chapters, that is chapter 1, 2, 3. And chapter 4, 5, 6, it will cover 6 chapters, 1, 2, 3, 4, 5, 6. Now, as you know, we were studying coordinate geometry with you. And after that, we have matrices. And after that, I will give you other tests, okay? And one thing, Amira, how was the quadratic equation problems? Did you have time to solve them? We had a few questions left, right? Or you didn't finish it?
Oh, those, yeah, I had a go at a few of them.
Okay.
Some like the ones that I didn't understand were like the wordy ones where you need to like decompose the problem and then solve it.
Okay. Okay then. So what you have to do is, if you have time, try to finish by Wednesday this test and also finish those questions. Let's discuss those questions on Wednesday. And after that, I'm going to finish coordinate geometry on Wednesday. We'll talk about circles, and I will ask you to solve some questions. If everything is okay, I will finish this chapter on Wednesday. Okay. So we will meet on Wednesday, right? Wednesday and Sunday. At Wednesday, I think 4:30 for London time, 10:30 UK time. Okay, Amira, that much enough for today. Thank you very much. Okay, see you on Wednesday.
Okay, goodbye.
Bye-bye.